Welcome to our Quantum Deep Dive.
Hey there.
Today we're looking into quantum particle swarm optimization, QPSO.
Right, and we're basing this on Jorgo Schneppet's essay, QPSO, Quantum Particle Swarm Optimization for Efficiency. Quite a title.
It is, and it really dives into why optimization is just, well, everywhere now.
Absolutely. It's not just one niche area anymore, is it? Material science, finance, robotics.
Machine learning, definitely.
Yeah.
But the problems are getting huge, really complex.
That's the challenge, Schneppet points out. High dimensionality, complex landscapes. It's tough.
Which brings us to particle swarm optimization, PSO. The essay mentions it came about in 95.
Yeah, Kennedy and Eberhard. It's a really cool concept based on swarm intelligence.
Like watching birds flocking or fish schooling, that kind of thing.
Exactly that. Imagine you have a bunch of particles, potential solutions searching around in this complex problem space.
Okay, so they're searching. But how? Are they just wandering randomly?
Well, no, not quite randomly. Schneppet explains each particle kind of remembers its own best position it's found.
Its personal best.
Right. And crucially, it also knows the best position found by any particle in the whole swarm. The global best, you could say.
Okay, so it's got its own experience and the group's experience influencing it.
Precisely. That mix of individual learning and social sharing guides the swarm towards better areas. It's pretty neat.
And Schneppet details how they adjust their, speed and direction based on these bests, plus maybe some inertia.
Yeah, there's an inertia term to keep them exploring, and then pulls towards their personal best and the global best. That's the classical PSO model.
And it's been useful, right? The essay mentions applications.
Oh, definitely. Schneppet notes things like tuning machine learning models, path planning for robots, signal processing.
Yeah.
It's pretty versatile.
But. There's always a but.
Yeah. Schneppet makes it clear traditional PSO isn't perfect, especially with those really tricky problems we mentioned.
They can get stuck.
Exactly. Stuck in what are called local optima. Good solutions, but not the absolute best one out there.
Right. A decent valley, but not the deepest one on the whole map.
That's a great way to put it. And it can also just sort of run out of steam exploring really vast search spaces efficiently.
Okay, so that sets the stage for the Q in QPSO. Quantum.
Right. This is the core of Schneppet's essay, using ideas from quantum mechanics to boost the optimization, QPSO.
How does quantum mechanics even fit in here? It sounds like a big leap.
Well, the key shift, as Schneppet describes it, is moving away from particles having exact positions and velocities.
Okay, so what do they have instead?
Probability distributions. So instead of saying a particle is here, moving this fast...
You're saying there's a chance it's in this area, like a probability cloud.
Exactly like that, a cloud of possibilities. And, according to Schneppet, this probabilistic nature is the game changer.
How does that help find the best solution, though? Does it make them search smarter?
In a way, yes. By using probabilities, each particle inherently covers, or at least considers, a much broader area of the search space simultaneously.
So instead of one little probe searching, it's more like feeling out a whole region at once.
You got it. Schneppet links this broader exploration, stemming from the quantum description, to a better chance of finding that true global optimum.
And less chance of getting fooled by those local optima traps.
Precisely. It inherently encourages more exploration. The particles aren't locked onto specific trajectories quite as rigidly as in classical PSO.
So this probabilistic element lets them jump around more, maybe escape those local minima?
Sort of, yeah. The essay explains the update rule in QPSO. It still uses the global best and an average position of the swarm, but there's this probabilistic factor woven in.
Which allows for more unexpected moves.
Yeah.
More exploration.
That's the idea. It makes the search less deterministic, potentially more robust against getting stuck too early.
Interesting. So Schneppet's essay, it sounds like it first builds the foundation optimization, then PSO.
Yeah, he lays out the groundwork, then dives into the QPSO theory, how it works, how you'd maybe implement it.
And then looks at applications and compares it to other methods. Sounds comprehensive.
It really is. He walks you through the thinking, how this quantum twist aims to overcome those PSO limitations.
So if we tie this together, Schneppet's argument is that QPSO blends swarm smarts with quantum probability.
To create a potentially more powerful optimizer for these complex modern problems, yeah.
And what are the claimed benefits, according to the essay? Does it work better?
Schneppet highlights a few key potential advantages. One is faster convergence, getting to a good solution quicker.
Okay, speed is good. What else?
Better global optimization capability. So actually finding that best solution, not just a local one.
That's the main goal, really, isn't it?
It often is. And interestingly, he suggests it might be less fiddly, less sensitive to the initial parameter settings than classical PSO sometimes is.
Oh, that's practical. Tuning those parameters can be a pain.
It really can.
And did Schneppet mention specific areas where QPSO could be applied?
He did. It echoes some of the PSO applications, but maybe pushes them further. Things like hyperparameter tuning in ML, feature selection, picking important data,
Useful stuff.
robotics path planning again, optimizing energy systems, even materials science and bioinformatics problems. A broad range.
Sounds promising. Are there downsides or challenges?
Oh, sure. Schneppet is realistic. Implementing QPSO isn't necessarily trivial. There's complexity there.
Right, it's not just plug and play.
And it can still be computationally demanding, It's not magic.
Still needs processing power.
Definitely. But he also points towards the future. Imagining combining QPSO algorithms with actual quantum computers.
Whoa, okay. Quantum software on quantum hardware.
That's the potential long-term vision. Could lead to massive efficiency gains, though that's still quite speculative, of course.
So wrapping up our deep dive into Yergo Schneppet's essay, it presents QPSO as this really intriguing bridge.
Yeah, bridging classical swarm intelligence with quantum mechanical principles.
Offering a new angle on tackling these really tough optimization tasks we face everywhere.
Exactly. It's a fascinating look at how borrowing concepts from fundamental physics might improve our algorithms.
Which brings us to a final thought for you, the listener.
Yeah, think about this. Schneppet's work uses quantum ideas for optimization. But where else might these core quantum concepts, things like probability being fundamental or interconnectedness, offer completely unexpected solutions?
Solutions to complex challenges may be far outside of algorithms or physics.
It makes you wonder about the untapped potential sitting at the intersection of different fields, doesn't it? A thread you can definitely see running through Yergo Schneppet's exploration here.